we're back at Math 70, and a number of questions have been raised about the test coming up Friday. So this is a good time to talk about the test on Friday. The first question: how many questions? How far or how much material will we cover? And I guess in terms of number of questions, I have in mind at least 20, under 50. I haven't written it yet. So I gave you an interval. X is a number, an integer, between 20 and 50. The closer it is to 50, the less likely. The closer it is to 20, more likely. So thinking in terms of an hour, 3 minutes per problem on the average, 20, but some of the problems take less than that, some a little bit more. So thinking perhaps more in terms of somewhere around 25 problems. Sounds a little more reasonable to me. And it depends on how many word problems. You will have at least a word problem. So the interval for word problems is probably between 1 and 5, depending on what I cover there. But I think realistically at least 2 or 3 word problems. You know, a mixture problem, a motion problem, something with integers. So you're looking at, let's say it's 25 questions, 4 points per question. And if you had 3 word problems, that's a letter grade if you don't do any word problems. Okay, so if I had 4 word problems at 4 points per problem, that's 16 points, and you can get everything else right and still get a B. But that's about the way I'd like things. If you don't do word problems, you aren't going to pull an A, and you're going to have trouble pulling a B. So word problems are important. So I guess that gives you an idea of where some of my emphasis will occur. And I think it's probably realistic to think minimally of 3 word problems and more along the maximum of probably 5, somewhere in there. The graphing, a big part of the test. Have a straight edge, label neatly, no graph paper allowed. You will need a blue book for the test. Blue book in the bookstore. And they are, what, about 20 cents a piece now? So you can get a couple of them. We get 4 of them for $1, more or less. And you'll need at least 4 of them because you have 3 midterms and a final. And so if you, on the final, take more than time to do a blue book, if you have 2 blue books for the final, which is not unrealistic with a 2-hour final comprehensive, probably 5 blue books would be a good thing to buy. Okay? And with that, again, as I say, probably question, how do I have to show things on the test? You'll show the original problem, certainly in everything except word problems. You'll write out the problem you're doing in the blue book, show me intermediate steps in your solution. And if you're doing a graph, then you document enough work that I know what you're doing. So the only other thing that I haven't really decided, and this occurred to me over the weekend in all the commercials on the Super Bowl, maybe some questions where you tell me in a discussion type question. So that's certainly a possibility where you might tell me some information from the standpoint of describe to me something, explain to me something. Okay? And to that extent, haven't decided on that yet. Certainly knowing formulas. May ask you just simply to write out the formula for slope, something of that nature. So those are the things that still aren't quite decided. As we go along, I'll try to give you more information. I've been focused on a lot of other things besides the test, and I'll be dealing with that as we go through these next couple days. Now, relative to the number of sections, we are going to certainly have you responsible for everything in the review in Chapter 1. That just goes with the territory. And then the material in Chapter 2 and Chapter 3 is going to be a very major concentration. And then material in Chapter 4 will go up probably through the first 2 or 3 sections, and that'll be included in the test also. So wherever we are by Wednesday or Thursday, we'll still be in the test for Friday. So the intent here is at least the first 2 sections. I start with Chapter 4 today, Section 2, maybe Section 3. And then the question, to what extent do I plan to do any review? And it depends how we are going through the material right now. Given the schedule I have, and it's not a schedule that lends itself to easily giving an extra day. The time isn't there. So don't count on a lot of review. The best you can hope for is part of the time on Thursday spent on review. And in some ways, to have it all thrown that fast in an hour and cover 4 sections of material isn't probably very productive. What you need to do is spend time on the problems that you've been doing in homework, and that does not mean you look at the problem and see it and say, oh yeah, I remember how to do that. It means actually sitting down with the problem and carrying it through, pencil pushing. I would encourage you to sit down and look at the material, particularly in sections 2, chapter 2, chapter 3, and the early part of chapter 4, and try to write out what you consider maybe would be a good dozen questions from that material. That's half of what I would give you. But try to see what you would create as a test. Make sure you can do those kinds of problems, and make sure you focus on what is an important idea, some more important than the other. I think one thing I mentioned to you very up front, and I can't emphasize strongly enough, you will be responsible for the properties of the real number system, writing them out as we did at the beginning, in symbolic format. Okay? And it would not be past me to just say, okay, here's 10 points of the test. That's 1 letter grade. Know the properties. Know how to write them out. So in that first chapter, that's a high priority. And then another interesting problem is, sketch me a diagram that represents the subsets of the real number system. There's that neat diagram in your book related to that. So that's one that appeals to me at the moment. What will appeal to me 3 days from now may change, but that's certainly some priorities there. Where you have there's a diagram about the real number system where they show the relationship of the integers and the counting numbers and the rational numbers and the irrational numbers. The real numbers then is the whole group, and find it. You'll find it, and that's not a bad thing to have you illustrate in a test environment. Well, let them search. Let them search. You'll find it. It's good for you. Okay, now, just a reminder, the video tutorials are out there, too. And I have completed those for all 3 weeks. Everything's there. And it's certainly, that's one way of getting some help. So if there's something you don't remember, try looking at the video tutorial. That'll be down to maybe 1.5 minutes, 2 minutes, maybe 3 minutes, but it's a nice way of reviewing. And I would just start going through the different links that are there and say, okay, that's something I don't remember, and maybe I should spend some time doing it. Things like intervals. I want interval notation that includes negative infinity and positive infinity as part of the notation. Does that answer a little bit about the test? It's closed book, closed note, no calculator, just in your head. All you need is your blue book and a pen or pencil. Eraser, straight edge, no graphing paper, no scratch paper. Everything is in the blue book. That's what the blue book's about. Okay, so you'll just have a blue book in front of you and the test proper itself. And that's the standard small version of the blue book, not the biggie. Pam, you had, I think, a blue book. Yeah, it's your whole, that's the one. You can use more than one, but that's the size you need. And by the way, give some thought to presentation. Don't put everything in the first 2 pages of your blue book so crowded, so messed up that nobody would want to read it. I react to that with hostility. Okay, and you want me happy, not hostile when I'm grading your paper. So to that extent, leave space, do your work neatly. If you can't do a problem, you skip some space and go on. It'd be unreasonable to do more than 3 problems on the same page. And you can use the back side, front and back side of the page. But don't sit there and put 15 problems on one page. Give yourself room. Make sure your explanations are clear. Presentation quality does count here. And if I think it's just impossible to read, I'll just take 10 points off the top and say this is impossible to read, and then I'll go ahead and try. But I'll take points off accordingly. So you need a blue book, no notes, no book, no calculator. Any other questions about the test? You will have 1 hour. And I don't know, this is a difficult thing to write a test in such a way that on the introductory material that is challenging enough for everybody and not so hard that people who are having trouble don't get totally demoralized. I like to write a test. I mean, my idea of an ideal test is you come in, sit down, work as hard as you can work for 60 minutes, finish the last problem in the last 30 seconds, and turn it in. That would be ideally what I'd like to see in a test. Realistically, you may find that if you know the material very well, that you're done in half that time. And if you don't know the material well at all, you may need 2 hours. There's a lot of variability there. And then one of the things that inevitably happens, somebody does as much as they know, they've left 15 problems undone, and then leave in 20 minutes. Bad idea. I would expect you to sit here and struggle with the problems you can't do until the time's up, instead of giving up on them. So if you leave early, it better be because you aced it, and you got it all, and it looks good. If you leave in 25 minutes, I expect to see a 90% plus in your paper with all the work done and really outstanding. If you're having trouble, you fight it through for the entire hour, doing the best you can, and just keep struggling at it and hope that in that time some things start clicking. Okay, any discussions? Yes? I have, well, the Saturday is for the group who are not in class. Yes, that's where we also are going to be on Friday. Yes, we will be in FH 123. So you will have a desk to yourself, plenty of space, and so we will be in FH Founders Hall 123 on Friday at 10 o'clock. So you don't need to be here then. If you come here and it's empty, that's where we are. So just count to 3 and you got it. 1, 2, 3. That's the room we'll be in. Founders Hall 123. Okay. Any other question? Good. Now, test discussion is over. How are we doing on the homework that you had? Are there questions about the homework problems, or are we really getting it now? Done Friday, you may have trouble remembering what you were doing then. But are there questions on the homework from Friday? If you do the work on Friday, you remember what we did on Friday, but then it's hard to remember it on Monday. If you waited until Sunday night to do your work, then you can't remember what we did on Friday, and then you're in double bind. So I don't know where the balance here. Probably what you should do is a half hour on Friday, a half hour on Saturday, a couple hours on Sunday, and then you'd be there. First, Coda.
Yes, sir. You did number 16 Friday, but we didn't get a chance. We didn't graph it.
Okay, page number?
That was page 208.
208, number 16, where we have 4 minus 1 and minus 2 minus 8, and then I asked you to go ahead and include a graph to get the slope. So no, I did not graph those points. Is it necessary to do that?
Yeah.
You would like to see the graph of those 2 points?
I'd like to see you do it. Please.
Okay, the graph of the 2 points. And it would help if I get some more chalk. I just realized I didn't have any sitting here, so. Okay, I need a coordinate system, so I'm going to quickly sketch a coordinate system. And just a reminder, the coordinate system should include all 4 quadrants, and they start up here when x is positive and y is positive. This is quadrant 1. Then they rotate in a counterclockwise direction. And for those of you wearing digital clocks, we still have the ones with the hands rotating in the room. So the way the minute hand is going is clockwise, and counterclockwise then is this direction. Okay. Giving you a low in a weather forecast. Now, we want a scale on here, and looking at the numbers I need, and it probably would be a good idea to get 16 there so you can see it. So let's try going to that, Debbie. There's the numbers, or the ordered pairs, and I'll just write those down here below. I have a 4 and a negative 1, and I have a negative 2 and a negative 8. And boy, did I not plan well. Okay, I thought I was putting them where I would not be having them in the way. So much for planning ahead. Okay, so there we have this. We're ignoring the door at this point. So we have 2, 4, 6. And so if I'm going to be at 4, negative 1, and this is going to be there, I'm going to bring that down here. So I have like that. And so this is going to be at negative 2. And so if I have 4, negative 1, I'm about right there for one of my points. Okay, and that I see is going to be hard to do. So I'll make the point a little bit larger there. And that's a 4. That can be seen better. And now the other one is going to be at negative 2. So if I think in terms of my scale at negative 2, and then I need to do what? Come down in an equal way. So this is negative 4, negative 6, negative 8. And if I'm coming down there, it looks like, again, so much for planning. Put the negative 8 on this side. But it looks like I'm going to be about right here for my other point. So those 2 points are seeming to be visible. And then what am I supposed to do? Draw the line between those. And of course, an important issue, and this is one that got discussed, and I am having trouble with my numbers I'm putting here, are not turning out to be in ideal locations anywhere I locate them. So let me see if I can get rid of that a little bit there and here, get rid of this. And this line that are these 2 legs of a triangle I've created become very important, and that hopefully gives you an idea of what slope is about. Because as I go from the first point, and I'm calling this point 1 over here now, so P1 is my point to the left, and P sub 2 is this point to the right. As I go from P1 to P2, I note that x started at negative 2 and went out to what? Went to 4. So that's a change of 6 units. Now as I go from point 1 to point 2, my y value was at negative 8 and has gone to what? Negative 1. So that is a change of 7. Now I'm not too worried about positive and negatives as I try to draw the rise and the run, because what am I going to use as my decision to whether it's a positive or a negative slope? If it goes uphill as I'm going from the left to the right, here's the left going right, it went uphill, I know it's a positive slope. If it were going downhill, then I know I have to have a negative answer. So in terms of just what I've done here, your observation is that the slope, now I'm doing it in terms of rise over run for the moment, is the rise, which is 7, the run, which is 6. Now the formula I intend that you use is instead y sub 2 minus y sub 1 over what? X sub 2 minus x sub 1. That now with substitution, and this is where I think you have to be very, very careful. And when I looked at what you did on the first effort of this, the sign errors were the thing that chewed you up. So again, common sense. If your line has a positive slope, make sure you get a positive at the end. If your line has a negative slope, going downhill, make sure that your slope indeed comes out negative. So what's the substitution I'm going to use here? Well, first let me identify this as P1, and this is P2 now.
Okay.
Now the minute I identify those, I can go ahead and pick up my y sub 2. So y sub 2 is negative 1. Then what?
Negative 8.
Negative a negative 8. In the denominator, I have x sub 2, so this was 0.2, so this 4 is x sub 2. So that's going to give me my 4 minus a minus 2. Now notice, I've got about as many minus signs in a problem as you could ask for. There's only one more negative I could have. This then becomes what? Negative 1 plus 8, a 4 plus 2, and I hope you realize that indeed that is the 7 over 6 that we have from our triangle. Now, there are obviously things that you can do. You can reverse P1 and P2. I think that adds confusion. I don't recommend it. And the key here is to carry through as much as you can, not cutting steps. I know it takes more time, but it pays off. And so what you want here is as much as you can to include everything that's going on. So it's overkill at the moment. But it's the kind of thing that if you do enough problems this way, I'm hoping that you'll remember. Pam.
You had emphasized a positive run. The P1 was always on the left. Even so, on a negative slope,
The run's still going to be
it's going to be
positive.
left. I mean, it's the
Otherwise,
point
if I
where-
always have P1 to the left, whether I have a negative or positive slope, my run is positive.
Well, what I meant is on a negative slope, P1 is still the one on the left.
Yes.
Okay.
But then what you'll always get is a
It's
denominator
negative.
that's positive, and then you'll either have a positive or negative with the numerator. And that makes life better,
Okay.
easier in the long run. Notation is your friend, not your enemy. So I think that's a very crucial point here, that notation helps you. Embrace it. Write the formulas. Show your work. Now questions. Harry, first.
In your set, if you designated the 4 and negative 1 as P1, I mean, how do
Then
you...
it changes simply which way both of these are reversed. I would have negative 8 minus a minus 1, a negative 2 minus a 4. You would end up with a negative 7 over a negative 6, which you would then wish to write as 7 over 6. But notice you've introduced more negative signs at the end, and that's where people tend to get messed up. So prefer P1 to the left, P2 to the right. It's not in concrete. Quicksand, if you go the other way.
If you were to look at the numbers and you say, okay, I'm going to use the positive 4 as my P2,
It's, well, what I'm
or
doing...
or the positive number as
Okay, but I'm looking at, these both could be negative, and what I ask, looking at the x's, which one is further to the left? So if this had been a negative 4 and this had been a negative 2, the negative 4 is more to the left than the negative 2. So you have to think of number line.
on the Y?
Oh, on the x-axis only.
Okay.
So you're just looking at your x values.
Okay, that's...
So you look at your x values first. The x that's most negative, the furthest to the left, becomes P1. Go ahead.
I just made a simple mistake. I see what I did. The sign got
Yeah, and the signs are the thing that are going to catch us.
came up with 7 over 2 instead of 7 over 6.
Okay, because you ended up, I assume, then with a negative 2 here
Right.
instead of a positive 2. That's where you have to be careful. Notice how that double negative rule we had earlier comes back and haunts you. And that's one of the things that I think is frustrating for the student learning algebra. One sign, error, and you're toast. Now, you can write English sentences and leave a period out and still maintain the meaning, and somebody says, you lost a period. And they understand what you're doing. You do an algebraic structure, leave a minus sign done incorrectly, and you get a totally different answer that messes you up and makes it wrong. So to that extent, algebra is very precise and very demanding. And you can't afford to lose your concentration and your focus. That is, I think, what gets most students. And there are very few areas in your curriculum, regardless of your major, that demand that kind of precision. Now, language study, if you're taking a language that you are totally new at doing, and there are certain languages that come to my mind, a little tilde here or there or a little diacritical mark can change meaning totally, and you can be very embarrassed just by missing one diacritical mark and get yourself in a lot of hot water in many languages. Again, the detail. What is characteristic of our current society about language? To be very sloppy, imprecise, and as we do so, a lot of the concerns about grammar and rhetoric that were very characteristic of a few decades back don't seem to be much of a concern these days, yet algebra is as demanding as ever in that language. We talk about jargon. In a sense, you're learning a jargon, and it is unforgiving in making small little errors that you'd say, gee, it shouldn't make a difference. Sorry. In the same sense as in arithmetic, misplacing a decimal can cost you millions of dollars. By leaving a decimal out in a 6-digit number can be very consequential. Same here. Other questions on this problem?
Different problem.
Okay, a different problem. Fire away.
I can't get it. Like,
What number?
3 on 207.
207 and which number?
Number 3.
Number 3 on 207. So I need to back up. Now here's where you started with the graph, right?
Yeah.
So let me get the graph. This is sort of the reverse process. Okay, Debbie, we can go for this. Now you have a graph, and you are fortunate to have grid points given to you, like the little lattice system, like a screen on it, because that allows you, leaving that on the board for a moment, this was number 16, I'll write that up here, and then in a moment I'll have Debbie cut to the board. But in number 3, we're looking at, and I'm just going to indicate the 2 points here in just a moment. Sorry for the delay, but the points are going to be a 1 and a 5. Is that correct?
Yes.
And the other one is a -1, -3?
Yes.
Okay, Debbie, let's cut to the board now. Now, I haven't given you the exact location, but I've given you the proximity. First quadrant and what quadrant?
Third.
First and third. Now, in this case, what are you supposed to do? What are you
Find the
supposed to
slope.
determine from?
Find the slope.
The slope, agreed?
Right.
So even if I don't know where the points are, I know that there's some triangle I could draw. And, okay, I need to look at the, okay, it looks like it's going through about there. Just looking where it seems to cross the x-axis. So what I'm really interested in is determining what? The run, the rise. Now, as you look at it, the 5 up here and the -3 tell you the relative positions of the y values. So if you're having to go from -3 to 5, this again relates to a letter I read from my aunt over this weekend. And they had been at -3 degrees and had a heat wave and went to 5. I talked with her last night, and she said it was going to get all the way up to 8.
Wow.
This is an island, so they're rather cold at the moment. So to go from -3 to 0 is the 3. 5 more means that you have a rise of what?
8.
Of 8. Now this is without the formula for the moment. And we went from -1 to 1, and I don't have that balance quite the way I should in terms of my scale. But it looks like your run is what?
2.
2. So I have rise over run, which is 8 over 2, which is 4 over 1, slope of 4. But what were you supposed to do?
That's how you get it.
Use the formula.
That's how I would do it from the triangle. Now how do you do it from the equation?
M equals
Okay, it's
2
back
minus
to,
y sub 1.
I mean, you have to memorize this equation. There is no option. You need to know that equation. Now, back to the question that Perry asked. How am I going to decide which one's P1? Well, -1 as x is to the left of 1 as x. So to me, P1 is that point down here. This is P sub 2. Now, the minute I've identified those, then this ordered pair becomes what? Technically, x sub 2, y sub 2. This point down here becomes x sub 1, y sub 1. And so all you are doing, once you've identified them, is substitute. I call it plug and chug. I was an engineering student for a couple of years before I went into architectural engineering and then before I went into mathematics. But at the time, you took formulas, substituted values, you plugged into it, sort of crunched the numbers, and out clunked your answer. Hence, plug and chug. Y sub 2 is going to be what? The 5, because of the way I've identified it. So I'm going to put the 5 up there, and Y sub 1 is?
Negative 3.
Negative the negative 3, and there's that double negative that we were talking about. Then X sub 2 is going to be my 1, then minus 1, another double negative, and that's going to give me the 8 over the 2, hence 4 over 1, and I have it that way, but you need to be able to see it both ways.
Okay, so it's like that one's the negative 3. Use the. Okay, I see where I couldn't get it.
Okay, I'm just substituting what Y sub 2 is, and X sub 2, and then Y sub 1 and X sub 1.
See, I wasn't using the negative sign. That one, I wasn't using that sign. That's why.
But see, that comes from the formula. That's why the formula first, substitution second, then your solution. And it at least allows you to see where the signs are going.
Yeah, I wasn't using the middle sign.
And that's very critical. Now, there's a quotation that I consistently address in the stat course. It comes from Bertrand Russell. A good notation has a subtlety and suggestiveness that at times makes it like a live teacher. Notation, critical. You're learning notation. To do problems without the notation will come back and haunt you. So use it, provide it as your documentation, and I will not give full credit in test problems without it. And what I'm telling you is you on a test can get all your right answers, but if you haven't shown me the appropriate notation and presentation, you will not get a perfect paper. It's that simple. On a 4-point problem, if I want a formula and you've left it out, you're going to lose a minimum of 1 point and possibly 2. Other questions on the homework? Perry?
On the homework? Yeah. Any one of 27 through 33.
27 through 33. Same set?
Yeah, 209.
Okay, so 209. This is dangerous when you give me my chance to choose. 27 through 33. Oh, yes. I like 31. Okay, let's go for it. 31. This is one of them, the choice, right? Okay, you gave me my choice, so I win. Now, let's look at 31 again, Debbie. 3x minus 2y equals 3. This is number 31, and let me write it before we take it off. 3x minus 2y equals 3, and I want the slope. What is the key?
Solve for y. Isolate
Solve for y. Isolate y.
Why? I mean, question. Why?
Okay. I thought you were saying why, like in why. Those, the Super Bowl commercials yesterday. Yow. Yo. Yow.
I didn't see any of those.
You saw the senator from China who was going to want to write a check or something? Yeah. And it says no checks allowed, so Yao comes to it, and the gal at the register says yo, pointing to the no checks. And he says, Yao. And she says, yo. And anyway, going on. Minus 2y is equal to minus 3x plus 3. Now, notice how the ability to make those changes must, at this point, for survival, be done quickly. Basically, in your head, adding negative 3x to both sides. You cannot afford, at this point, to have to show that as a separate step. Then you must be able to divide both sides of the equation by negative 2 and do it in your head. And y is then equal to 3 over 2 times x minus 3 halves, where you adjust to the signs on the fly. Now, the why of wanting this form is to acknowledge that the coefficient of x is what?
3/2.
The slope of your line. Now, I will ask you to remember a problem that we spend considerable time doing in formulas, where I ask you to solve for what? Y. Remember that problem? Where we solved for y and we ended up with minus a over b times x plus c over b. And I called that what form? The SI of math, the slope-intercept. And this coefficient of x was the slope of your line, and the form that typically takes, we're going to find, and I've been talking about this, mx plus b, where m is the slope and b is the intercept. So once I get an equation in that form, what am I guaranteed? That the coefficient of x is the slope of your line. Hence, m in this case is 3/2. Okay, I'm getting the look that says I haven't communicated. Perry, question?
Start again.
Rewind. Okay, I'll go to your question to avoid Perry's doing.
You said positive, not negative 3/2, positive 3/2.
Well, if I divide by a -2, I'll have -3 over -2, which is 3 over 2.
I have a problem with science. It's not your fault. It's my fault. I got a problem with science.
I hope it's not my fault. I would
I
not
got
want
a
to take
problem with
responsibility
science.
for that. But the quotient of two negatives numbers must be a positive. Now, at the moment, okay, I'm going to come back and try to deal with Perry's frustration here. First point, if I give you an equation in this form, for the moment, you're going to have to more or less accept a definition here. That once an equation in this form, you can accept for the moment as sort of a statement of, okay, I'll accept it for the moment. It's being accepted on faith that this is going to happen. That when you have it in this form, the coefficient in front of the x will be your slope. You'll have to accept that as a premise. Okay, if you can get it in this form, then that will be the slope of your line. Now the proof of that probably is at first best done by getting two pairs of numbers that satisfy this equation, like you're going to plot it. So for example, if x is 0, y is what? X is 0, that term goes out, agreed? And y is equal to what? -3 over 2, although you could say 3 over -2, it is more common to put the negative sign on top. Okay? One ordered pair. Let's go for another ordered pair. Guess what my favorite typically is? Y is 0. Let's go for the other intercept. If y is 0, what's x? 1. I have a pair of points. I could now find the slope, agreed? From that pair of points. Which one is point 1 and which is point 2? This is point 1. This is point 2. Okay? Now, back to my formula. So I'm going to say, where am I going to say that? I'm going to say it down here. M is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And if you've written this enough times and it becomes sort of melodic and boring, then you remember it.
How did you get the 2 points again?
I let x be some number
Okay.
and solve for y. I like to let x equal 0. That's just my choice because it makes it so easy. And then I say y equals 0 and solve for x. Those are the two intercepts.
And how do you get the 1 though?
How did I get this one?
Right.
Okay, if y is 0, 3x is equal to 3. X is 1. Okay. 3 times x is 3. X equals 3 over 3. That's 1.
I got it.
Okay? Continuing or not?
No, I just wanted to ask a question.
Okay.
Where it says y equals mx plus b, what
Yeah.
did you call that now? Is it
Slope-intercept form for a linear equation in two variables.
and then the one of the ax plus by is equals c?
That's
It's
the
just a
same
slope.
thing. This was just a general two-variable. This became the slope.
Into.
And this becomes the intercept. But we just, as a generic statement, say mx plus b. That form. So I'm giving you a kind of That's the form I want it in. It's a little bit like when you put down the date your credit card expires and they want it in a 4-digit second field, so you have 2000 something rather than 03. They've given you the form. That's what I'm giving you here. Now are we ready to plug? Okay, so y sub 2 is
0.
0 minus
Negative 3.
negative 3 halves. Hence, that is a
Positive.
positive 3 halves. Ah?
Correct.
You're a hard audience right now. Okay, x sub 2 is
1.
1. X sub 1,
0.
0. 3 over 2 over 1, which is
3 over 2.
3 tooths. 3 halves. Now, which was easier?
The other way. That one.
They may both be confusing, but one's less confusing than the other. Which would you prefer? I think finding y by itself a little bit easier. Therefore, you find the slope by looking at the coefficient of x once you solve for y. Now, I'm giving a message again here. I've spent a lot of time on this problem. If there's one thing you, by God, better know when you get out of this class, it better be this. Because when you go into stat and you don't, and you tell me you have my class, you will leave. By invitation, and only return when you remember it. Debbie, I'm going to go to the side of the board. So will you take camera 2 and rotate it over there? We're going to leave this on the board here for a moment. Then we're going to go to camera 2 on the sideboard to where you see the stat presentation. So we're letting Debbie make some changes, and I'll just leave this here, and she's going to take the camera over here. This was from the stat lecture. Notice where it starts. Y equals mx plus b. And notice a familiar formula. The slope. Now this particular problem was to illustrate a problem about homework, which you're familiar with. 5 problems, 2 hours was what I plotted here. So this was the point I plotted. 5 problems, 2 hours. 10 problems, 4 hours. 15 problems, 6 hours. That was the argument. I asked them to give me the equation of the line. They had to find the slope. The same problem, just asked. This line goes through 0, 0 because 0 problems, 0 hours on homework. Now what I did was carry this one step further. Now here's another approach to it. And this is worth seeing. It's worth the price of admission today. There's my equation. I know the intercept is 0, so I just put the 0 in there. Because I know it went through the origin. That b value is where the line crosses the origin. Now notice, because Perry, this gives you an alternate solution with that equation. If 0 is the intercept, and I have the point 5, 2. That was a point that said for 5 problems, 2 hours. Could you then solve for the slope if you know the intercept? The answer is yes, because y is 2, x is 5, so you have 2 equals 5 times m. m is 2/5, so your slope is 2/5. So y equals 2/5 x plus 0. And that has to roll off your tongue without problems when you leave this course. There's been a lot of discussion today, and I've spent about 20 minutes more than I usually spend answering questions. Perry. Back to there. Okay, we'll leave this up here, and Debbie, take camera 1 and kick it over to the side.
When you said P1 and you had the solution set of 0,
That's not a solution set. That is an ordered pair.
ordered pair,
So P1, ordered pair.
shouldn't it be negative 2?
Negative 2, negative 2, negative 2.
Talking about the denominator.
You had 3 over negative 2?
Right, because we're saying,
X is 0.
right?
So you have y equals 3 over negative 2? Yes?
Yes.
Okay. 3 over negative 2 is what you had. I had negative 3 over 2. They're the same.
Could you put negative 3, 2? And it's the same.
And I could have had negative
Okay.
3 2s.
No, because when we said y equals ax, a, b, a over
Minus
b.
a over b. Minus a is 3.
Right, because
Minus 3 over b, and b is what? Negative 2.
negative 2, that's what I'm saying.
Now, if I do that, let me check. I indicated my slope was 3/2, which is consistent, because I would have negative 3 over negative 2, which is 3/2. That is different than the y value for x at 0. Those are two different issues. When x is 0, y is negative 3/2. The slope happens to be positive 3/2. But note, this negative 3/2 has 3 different possible representations. Which is most characteristic in algebra? The second one, with the positive denominator. Other questions on this? Okay. Leave that up there for a moment. The particular intent of this problem had to do with an equation somewhere. Let's see. Page 205. 2 steps involved. Finding the slope of a line from an equation. Solve the equation for y. The slope is given at the top of 205. Is given by the coefficient of what?
X.
Of x. All I have done is give that statement a symbolic representation with an equation. Y equals mx plus b. When you get y by itself, you'll get an equation of this form. M, the coefficient of x, is your slope. And O, by the way, and we don't need to delay it, that letter B, whatever it is your y-intercept. So when I solved down here and got negative 3/2, I immediately knew what? That's where the line crosses the vertical axis at negative 3/2. And look, when x was 0, y was what?
Negative
Negative
3/2.
3/2. Here's what I expect of you based on today's presentation. That you could go into a room with a blackboard and you could give the explanation on slope and intercept starting with an equation or a graph, get the slope, and explain to a person what's done. That's what you should be able to do based on what we've done today. When you can do that, you own it. Until you try it. You may not understand it as well as you think. When you try to explain it, I think the little pieces, those little pieces right now that are elusive to you, will make sense. Seriously. Part of your homework. Explain how we did today's presentation. If necessary, to the refrigerator door late tonight when nobody's around to hear it. If possible, if you have a cat or a dog, explain it to them. They are non-judgmental, non-argumentative. Get a parakeet, goldfish, something that will listen and give you a feeling you aren't talking to the doors.
What if you live alone?
All the better. If you live alone, you can just sit there and mumble to yourself and nobody cares a rip. That works best. But you need to explain it. What would even be better? Try to get somebody who will sit down over a cup of coffee, lunch, dinner, pizza, beer, and explain to each other, take a shot at it, explain to each other, trying to explain this idea. It is by far the best way to understand something like this. And how important is what we're doing today? Important enough, I've spent 50 minutes of our time on something that I should have technically walked away from and gone into the next section. Folks, I can't give you a stronger statement of its importance than when I basically give up a full lecture to hit this home. Okay? A very good test question. Explain how you generate the slope of the line from an equation. Explain it in words. Use 2 or 3 paragraphs illustrated with diagram for 5 points on a test question. That's possible on the test. Okay, I'll leave that alone. There's one other idea that I didn't do. Slopes of horizontal and vertical lines. First, we've talked about this briefly, but it's necessary to say it in more depth. So we're still on slope. Horizontal lines have a slope of 0. Think of what the form of a horizontal line is. It is y equals some number, like y equals 3. Technically, 0 times x is part of that equation. So if I have a horizontal line, y equals 3, it's 0x plus 3. Horizontal lines have 0 for a slope. That becomes critical. I'm on page 204. 204, middle of the page. Then vertical lines. Come back to that now. Vertical line, x equals some number, like x equals 3. X is equal to a constant. There is no slope. It's undefined. That is important. Those two statements you must remember if you're going to go on in mathematics. Horizontal lines have 0 slope. Vertical lines have an undefined slope. And then, something we talked about today in the stat class that I would expect you to know. Page 206. Lines that are parallel have the same slope. Lines that are perpendicular have slopes which, when you multiply the slopes together, you get -1. So I want that to come back to that statement again, Debbie, if you will just come back to that. Let me just illustrate that. Let's do it on the front board still. I'm going to write 2 equations up here. Y equals, let's see, in the form we had, 3/2 x minus 3/2, and now I have a line y equals 3/2 x. This one goes through the origin. This one goes through the point -1.5. Those are parallel lines. If I had this line, y equals -2/3 x, it is perpendicular to the other line. In fact, it's perpendicular to either of the other lines. Reason? Look at their slopes. 3/2 times -2/3 gives you what? -1. Therefore, the lines are perpendicular to each other. We say they are at right angles to each other. The fancy word in mathematics is orthogonal. Like ortho, ogonal, orthogonal, perpendicular. The symbol for perpendicular is an upside down T, perpendicular. Back to the page on the book. So if you have 2 equations, such as are given to you in the book, right below that presentation, Notice the way they're given, it's hard to tell their slopes. So what do you have to do first? Solve each for y. Let me darken that a little bit. You solve each for y, and you get a negative 1/2 x and a what? Positive 2x. The product of those two slopes is negative 1. So the argument is they are perpendicular lines. And disguised as such until you get them in slope-intercept form. Now I'm going to assume that today was a review. So to answer your question, am I reviewing? Yes, I did it today. That was the day at best I'd hoped to review. So to that extent, I would spend time tonight test preparation and study chapter 2 and 3 with a vengeance. This is your one night of review you're getting before the test. I will continue to cover new material up through Thursday, which will be included on the test, probably up through Wednesday's material. So no formal homework assignment tonight. Just spend 5 hours preparing for the test. So with that, Debbie, we're going to close. Can you wait, please, people? Have a seat until we are done with the presentation. Debbie, by the way, I will need homework turned in, please. So as you leave, you'll turn in homework. Debbie Los Lobos, then?
Yes, we're in.
I love you, Debbie. Have a pleasant day.